you understand the idea that there are three types of factoring problems that I've taught you. You understand that there's a difference of two squares. There's square trinomials and there's just old school normal build the shells. So if you are really, really good and you've finished assignments 45 and 46 and you've graded them and you've like, you don't even need to listen to what I'm about to say. This is for the 75% of us that still feel like factoring is something that is a little bit challenging. Step one is to pull out the GCF. So that's always going to be step one. And I will harp on you if you decide to take Algebra 2. We're going to have this conversation a lot from like August to the beginning of October is GCF, GCF, GCF. But assuming we pull the GCF out, what happens after that is your problem divides into one of two categories. It either becomes one of the short ones with two terms and a minus. What do we call that again?
Oh, a square,
Called a difference
a difference
of
square
two squares.
of two.
So you
Okay.
can call it a difference of squares. You can eliminate the word two if you want. It's no problem. Or your polynomial is going to have three terms.
Let's say
And the signs don't matter here. And this is a build the shells problem. Do you understand that? And again, I don't really know who I'm talking to because I know there's a bunch ignoring me because you already know all this, but like you need to be able to compartmentalize every problem and say, who's my opponent here? So like in problem number one, after I've pulled out my GCF, I'm left with this three times the part of the problem that matters. This. And what category does that fall into? Is that a difference of squares or just an old school build the shells? It's a difference of squares. And the difference of squares at some point will become your favorite. Why? Anyone who gets it already knows this. Why are these better? Say again. Right, because you don't have to guess and check here. The difference of squares, if it's not today and it's not tomorrow, hopefully by Wednesday you will understand with perfect clarity that they're the easiest in the world because there's no guessing. You follow a pattern with a difference of squares. You bring down your GCF of three, and then the things you build are not guessing.
you already know it's
What's the
3x,
square root of that?
3x.
So you put three X's in the fronts. What's the square root of that? So you put ones in the back. And what signs do you put? This is the one spot that continues to be a holdup is that there has to be one of each because look at where this green arrow is pointing. What's there? Nothing. And the only reason there's nothing there is because I make nothing there by making sure I put a plus on one of the three X's and a minus on the other. You must understand fundamentally that that's why factoring a difference of squares works the way it does. You have to have one of each to make the cancellation. And if someone were to say, should I write this the other way? My answer is, what are you talking about? There is no other way. This is the final answer. You cannot write this using exponents because the factors aren't the same, right?
Mhm.
And for those of you who are kind of following along, I would just do one more and then I'll shut up, but I'll sort of force the issue. Problem 5 is a great next example for us. Problem 5 looks scary, but once I do my job and you do your job and we come together and figure this out, you realize nothing scary about it. What's the first thing we do?
You find the GCF.
Thank you for saying that. Thank you so much. It's not about shells. It will be in about a minute, but right now it's about finding something that they can all. And this is where having a calculator is pretty critically important. What's something that 24, 68, and 56 can all be divided by? I agree. So you might want to not write this down because you're going to learn something here. But I'll take one for the team. If I pull out a two, I'm left with 12 of those, 34 of those, and 28 of those. And then it occurs to me, I'm like, ah, snap. I got a problem. What can all of these be divided by? 12, 34, and 28 can all be divided by. The fact that you find yourself being able to divide again means that if we could go back in time, it means we didn't divide by enough in the first place. So let me ask you this again. Yeah, the answer is 4. When I said, what can these all be divided by? You weren't wrong when you said 2, but 4 is the G in the GCF. Don't settle for like an SOCF, just some old common factor. Like you want G, that means something greatest. So we're going to pull a 4 off to the side.
Do 4, and then you do the
What's left?
what?
6x squared minus 17x's minus 14. And that took more than a minute, but you'd be surprised how often the GCF can be a holdup of a step. It's just basic division. If you divide and realize you didn't divide by enough, you can keep going and compile your GCFs into one, or you can just start over, go back to the drawing board. At the end of the day, this is what we should all have for problem 5. Now, going back up to what I said a couple of minutes ago, this is where in my notes, I'm going to remind myself that I'm going to compartmentalize problems into one of 2 groups. It's either the green group or the purple group. And for some of you who are already really good at this, there's another group. We're not talking about that ever again. Is this green group or purple group? Purple group. And what is our reminder? What do we do with the purple group?
So
We build shells.
sorry.
And so I'm going to
Ayana.
have my 4. And I can actually, you don't even have to put the 4. Like as long as you remember it later, let's just focus on the part that I'm underlining. So what would my shells say?
6x, 6x.
6x is
X, sorry.
one of them, and so is x. But there's another pair of shells.
3 and 2.
Correct. And I'll tell you what, if by Wednesday I have succeeded in getting all 54, 55 Algebra 1 students to know this, I will probably, treat myself to something nice as a reward. Yes, I'm going to go get some tacos. What will the signs be in this problem?
Minus, minus.
I want to know before Wednesday that every one of you knows that there is one of each. And just now I heard 2 incorrect answers. And we're far enough along that, we still have 47 hours and 50 minutes to get this right. But if you say minus, minus, you better be able to justify to me that your 2 minuses are going to multiply to make that negative that I'm pointing at. And it all comes down to the number in the back. And if he's a negative, he says, I am the boss of this problem. Whatever numbers you put in these 2 blanks have got to multiply to make me. And the only way to do that is with one of each. If you're looking at the 17, then I'm continuing to fail you. I'm not saying it the right way. I'm not clicking with you yet. We haven't vibed it yet. This has nothing to do with anything other than the minus on the 14 in the back. He says, you're going to pick 2 numbers that multiply to make me. You need a negative and a positive. That's conversation over. Done.
Well, I thought the 14 tells you that.
It tells me that there's one of each because he's a negative 14, right? And the only way for these 2 numbers in these big yellow boxes to multiply to make negative 14 is a positive times a negative, right?
That doesn't make sense because if it's one of each, then why is the 17 negative?
Okay, I'm going to say this again. You should not be looking at anything other than the number in the back. It's all about the number in the back. I crossed all that off on purpose because I don't even want you to know what's under there. If the number in back is negative, then the conversation is over. These 2 numbers right here will multiply to make negative 14. That's what this number in the back says. The 17 has no say in this. We'll do a problem here in a little while if you'd like. I can show you that there are times when the number in the middle actually matters, like number 20 or number 14. But in this case, the 14 says it all. He says, if I'm a negative, there's one of each. Don't worry about the 17, okay? We'll make him later. And I mean, if I can get you to jump all three of those hurdles, ah, boy, we are victorious as a team. Hurdle one was, for God's sake, get the GCF out. Hurdle two was to build your shells and know what to put in the fronts. And the massive hurdle number three is, can we get the signs right? From here, it's just a guessing game. What are we trying to multiply to make?
-17.
Nope, we're still fixated on that 17. Forget the 17. What are we trying to multiply to make? 14. And you don't even have to say negative because we already have the signs done. So you just got to test 1 and 14, or 14 and 1, or 2 and 7, or 7 and 2.
We should do it.
And when we get lucky, we'll know because the magic will happen and we'll get that -17 in the middle. But that's not our goal. Our goal is to multiply to make 14. Our secondary goal, the bonus, is when we make the 17. Ooh. What do you want to try? 7 and 2. Which template would you like, top or bottom? This one? So you want a 7 here and a 2 here? I need you to understand that the probability that this is correct is 12.5%. So that means that there's an 87.5% chance that this isn't going to work. So I don't want you to get bent out of shape when it doesn't work, okay? Accepting failure is part of being good at factoring. So maybe we got lucky though, you know? You tell me there's a 1 in 8 shot. Maybe. Let's find out. What do those make?
16.
No.
Negatives.
Yes. And what do these make?
14.
And if you add -6x and positive 14x, what do you get? And that's not what we wanted. We wanted to make that -17 magically. So as expected, when you have a 1 in 8 chance and you guess, you're probably going to be wrong. So it didn't work. So what else would you like to try?
Do we flip them?
You can flip them. And I'm really glad you said that. And you'll be really glad you said that too here in about a minute. Because I had a guy earlier, we were doing this problem together, and he thought after this that he was done with 7 and 2. And it's like, whoa, what a shame to think that we're done when all you have to do sometimes is switch them and see if maybe that's the solution. Oops, I didn't switch them, did I? My bad. 2 here, 7 here. And watch how that changes the whole magical dynamic of the problem. Like the whole thing is different now. What do the 2 outside ones make?
Negative.
What do the 2 inside ones make?
4.
What's -21 plus 4? Which is exactly what we wanted, which means we did it. And had you not thought to switch the 2 and the 7, we could have wasted several more minutes. So the final answer, one of the most common mistakes that I see is people, and Cody and I were just talking about this, is people sometimes say, hey, there's my answer. And then I unfortunately have to take a point off. What did I forget? Forgot the 4. The GCF is part of the deal. Like, so putting him aside is one thing, but you can't make the timeout far enough away that you forget. So, I mean, that's what I have to say as far as like generally, how do you do this whole quiz? Is there's difference of squares, which you do a pattern, and then there's shells, guess, and check. That's the whole quiz in a nutshell. So I'm going to pause this, and then any other questions you have, I'll just answer them recording wise.
Oh, wait.
Number 3. So let's just pretend that it's 48 hours from now and you're taking a quiz and you get a problem like this. What is the first thing every one of the 19 of you will do? We will look to see if there's a GCF. And that just involves basic math. Is there anything that 10, 47, and 9 can all be divided by?
No.
You mean you're all correct. If you say no, correct. If you say 1, correct. Bottom line is we checked, we did our due diligence, we moved past it. And we recognize that since it's got 3 terms, this is a shell builder. This is a roll up your sleeves and get her done problem. There's no pattern, no shortcut. It's just this, shells. What's going to go in my shells?
10K and K, and then there's 5 and 5. No,
Five
wait,
and
5 and 2.
5 and 2.
Sorry.
So if you've made it this far in problem 3, you've cleared some hurdles. Hurdle 1, you identified that there is no GCF. Hurdle number 2 is you built your shells. And now comes the killer, the one that quite frankly defines or decides F's and B's. Like you get this, you're at least probably a B or a C. You don't get it, you can't get higher than like a 31%. What are the signs?
Plus.
Both pluses. And we're not sure of that right away. We're sure of it because the number in the back says they have to be the same. Then we do, in this case, defer to the one in the middle who says, oh, BT dubs, they're all pluses. And that's where I, as your math teacher, if I can get you to that point, I feel pretty proud of what we've accomplished. It's at this point that I step out and say, okay, now let's see what they can do. And the question is, do they understand that we're multiplying to make 9 and that we don't give a flying rip about the 47, correct? We're going to make a 9. That is our objective. And if the 47 happens, when it happens, we'll be victorious. So there's 3, 3, 1, 9, 9,
9 and
1. So there are 6 ways that you have to test.
You can do 3 and 3 on the bottom.
Because there's 3 things, but there's 2 templates. And so you want to try 3 here and 3 here.
Yes.
I'm fine with this. What is the absolute worst thing that happens? It doesn't work. And I, maybe shed a tear or two and then laugh about it and move on and try something else. And the way we test to see if it works is with, bless you, with this times this and this
15.
times this. And if you don't draw these yet,
15.
and you don't have to if you're getting these right, but if you're struggling at all and you're not drawing the purple things, I tried drawing one low and one high to see if maybe that would make it a little different. I don't know. It's all about the purples. What do the outside purples make?
15K.
What do the inside purples make?
6K.
And what's 15 plus 6? 21, which is not what we wanted. So, we don't get all butthurt about it. We just go, no big deal.
Let's just try again.
Try something else.
We can do 1 and 9. We can do 1.
And there's 2 kinds of people in this world, and you're bringing up an interesting dynamic right now. There are people that say, I am going to stick with the 3 and 3 until I'm sure. And that's what Rain just said is, what could I take the 3 and 3 and try them up here? Yes. So you're either a stick with a pair, tried in all the templates person, or you're a stick with a template and try all the pairs. And I couldn't care less. But since Rain said it, let's try it. If we try the 3s up above, what are the 2 in the middle? The 2 on the outside? And we can see that that fails. And what's nice about that is, to some extent, there's some peace of mind, because it means that I can now lay 3 and 3 to rest and say, you won't work anywhere. I just proved that. Right? So you pick. I don't care, as long as you pick a system and stay organized. You don't want to miss this because you're not organized and you don't know what you have and haven't checked.
Can we do 1 and 9?
We can do 1 and 9 on the bottom. Absolutely. I believe that you're right, but let's make sure. Let's just go through the motions. Let's try 1
It's 44.
and 9. I'm trying to give a certain vibe when I go over these so that you feel it too, that this isn't about expert. This is about trial and error. What do the 2 on the outside make?
45K.
I agree. What do the 2 on the inside make?
2K.
And what's 45K plus 2K?
46.
Which is exactly what we wanted. Which means that we can put a box around this. Always make sure to go back and check, was there a GCF? And the answer is no. So just sometimes people forget to bring it down. Did you have a question? Sure. What's step 1? Is there one? What is it? I agree. So in problem 8, you need to pull out a 4. And Tessa, what's going to be left if we pull that 4 out? Squared. Thank you very much. So I need you to make sure you understand that at this point, the 4 and the parentheses don't matter. Like I'm going to get rid of that and so I'm going to bring it back. But you understand that our focus is just that, right? Okay. So we're going to factor what is left in the parentheses, which means this is a shell problem because it's got three terms. And what's going to go in the fronts of our shells? And this is the one where if you give me 53 kids, and if I get 52 of them to answer this right, I'm still a failure. I want all 53. What are the signs of my answers going to be?
Positive, negative.
Do you get that? 100%? Because the number in the back is a negative and nothing else matters. So there has to be one of each. And now there's only so many ways to multiply to make 10. What do you want to try? So how do you want me to put it? Like 10 first and then 1 second? Okay. And do you know how to test it to see if it works? Are you done with me then?
Yeah.
So there it is.
Completely forgot how to do all of it.
That's it. Game over. And I didn't draw my purples that time. So anyone watching this or anyone kind of half listening might say, oh, it's done. But of course, you knew that those on the outside made -1 and that these on the middle made +10. -1 +10 +9. Jackpot.
I'm gonna go back to number 2 now.
Number 2 brings up an interesting point. And this, I've said this before, and you still probably don't even know what I meant because I talk a lot. I have thoughts, they come out and you're like, what's the man talking about? I wish I had never mentioned square trinomials. That day where I said square root this and square root this and multiply them together, I wish I could go back. And I know now for next year and the year after that I'm just not going to teach it. I'm going to say kids are going to discover squares when they're ready. Number 2 is just a normal problem as far as we know. Clear? So step 1 is I ask myself, is there a GCF? And the answer is, of course not. There's nothing that 1, 8, and 16 can all be divided by. So we move on and we make our shells, right? So after we make our shells, then we know that we have to put a 1K here and a 1K here. And this is it, the hurdle. Number 1 on my list of things to do this week, today, is can I get them all to answer this question correctly without guessing? What are the signs?
Plus one of each.
Negative, negative.
And if you're still saying one of each, I am still failing you
How is it not?
because the
Same
number
sign at the-
because the number in the back is a plus. And the way that that number is going to come into existence is by the two numbers in these blanks multiplying together. The fact that you're saying one of each tells me you're probably looking at something like over here. And I got to keep reminding you that this isn't about that. The numbers in those yellow blanks are going to multiply together. And when they do, the answer has got to be positive 16. And the only way in math for two numbers to multiply to make a positive is for them to be the same. They must either both be negatives or they must both be positives. It's all about the 16. So the question now is, are they both pluses or are they both minuses? And the answer is, well, they're both minuses, right? Because the 8 tells me so. So I'm going to put a minus and a minus. And what numbers are we looking for in this case? Your options are 1 and 16, 16 and 1, 2 and 8, 8 and 2, or 4 and 4. Those are all the factors. What do we
4.
want? We want 4 and 4. And eventually you realize that, oh, this is what that whole dumb, by the way, I think I delivered a great lesson. I just should never have delivered it. This answer is not what I want. What do I want?
You can do K,
I want this
4, and then square root.
because the factors turn out to be the same, right? And that goes back to that dreadful day when I taught you about square trinomials. I gummed it up. I should have waited a week. So that's how you do any problem with three terms is build your shells, make sure you know how to do the signs, and then grind away till you get it. Does that make sense? 100%?
Yeah.
Okay. just recording all my interactions today. So we have this. And the first thing we check for is there anything that's a GCF? And the answer we figure out is no. 4 and 25 are like, they're what we call relatively prime. Means they can't be divided by anything other than 1. So now we move on and we recognize that as a difference of squares. What I need you to really figure out before Wednesday is this. There is, in the middle of this problem, a gap. And if it helps you to see it this way, see if I move that 25 over there like that, isn't there something in the middle? There is. It's a 0. And I need you to understand that the only way to make this happen is to make things cancel out. The canceling is what makes the magical 0 happen. Do you understand? So you're connecting a lot of the dots here. You're figuring out that the square root of that is 2r. And you understand that the square root of this is 5. But the one missing piece for you right now is that this isn't going to work because I can't do 2 of the same thing or they'll never cancel out. I need to understand that there's going to be one of each. There's going to be one that has a plus and one that has a minus. That's the only way the 0r is ever going to make it. So you're doing great when you identify the 2r and the 2r. And you're doing great when you identify the 5, but you see that they cannot be the same because the goal is, what do these make? Negative 10r. And what do these make? Positive 10r. And you see, by making sure that there's 1 plus and 1 minus, I made sure that those negative 10r and plus 10r would make the 0 that I was trying to make. So the answer cannot involve an exponent because these literally cannot be the same. The answer is the plus and minus pattern. It's got to be a plus and minus pattern to make the middle term go bye-bye. Does that make sense? For real? Okay, so that's going to be your strategy with anything that's a difference of squares, like number 6 or number 16 or number, well, that's it. I think there's not a whole lot of them on here. I probably should have put more. I'll put some more on tomorrow's practice quiz, some more difference of squares. So number 17 is 20 of those guys plus 28, the linear guys, minus 24 constant. I got to ask this, and you can't miss this. What's step 1? Right. And if there isn't one, fine, but I do believe there is. What do you think it is?
4.
I do too. So I recognize that all 4 of those numbers can and need to be divided by 4. So I take the 4, I set it off to the side, and then I rebuild. Each of these terms gets a new version 2.0 of himself. 20 becomes 5. 28 becomes 7. And 24 becomes 6. You still with me? Now, because it's a 3-term polynomial, it's just a very standard quadratic. I'm going into build the shells mode. And so the shells can only be done one way because 5 is not a very fruitful number. So I would assume, I know you asked for help, but I would assume by now that you've got this. And this is it. Again, the question that I feel like if you're not getting this question right, come in for lunch, stay after school, come in for flex. You keep coming in until the answer to this question makes 100% sense to you. What will my signs be?
Positive and negative.
1,000,000% one of each. And when I say why, if a kid says, oh, because this problem has one of each, then I'm continuing to fail you. It has nothing to do with anything other than the 6. If the 6 is a negative, then there is one of each. That's enough. I don't even have to give a rip about the 7. I only go to the 7 if I need to. So I'm going to do one of each like this. For those of us that are still working, do not be distracted by those that are packing up 3 minutes early. Okay, we're going to keep working. The distractions shan't bother us. So I'm still talking back there to you, since this was your question. What do you want to try?
3 and 2.
In that order?
Yeah.
Okay, so you want me to put a 3 here and a 2 here, because those do make 6. And have you tested this yet?
Not yet.
Let's test it and see. We're going to get some good news, bad news here. So what do these two on the outside make?
Negative.
Negative 10x. What do these two close ones in the middle make? And what's negative 10x plus 3x? And what is that what I wanted?
Well,
You just have to switch the signs because we got the, I always hate to say this, the right number, but it has the wrong sign. So whenever that happens, don't mess it up. Just change your plus minus in this case to a minus plus. And the last thing I want to say about this, Ollie, is if a kid goes like this and says, there's my answer, you've seen these this year, you're going to get the -1. Why? No,
Oh,
it's because I forgot the GCF. And so make sure before you say, here's my answer, that if you put a GCF in timeout, that you remember to not leave him there. Got it? I fully expect that by the time I see you tomorrow, that all 20 of these problems will be done and ready to grade, and that you'll be ready for practice quiz version 2. So if you have the same amount done tomorrow as you do right now, don't tell me that because it's not going to be a conversation that you're going to want to be a part of. Okay? Get them done. You got 23 hours and 10 minutes to get the rest done. That's a lot.
If you can't sleep at night, just